Everybody, this is take 3 for me, so I'm super excited to be doing it again. And this is our last lab. Again, I'm also very sad about that because, hey, who doesn't want to do more physics labs this summer? Hi, everybody. My name is Samantha Nuzema, and this is our last lab on oscillation. So let's talk about it. Um, Besides trying to further our education, why are we doing this lab? What's the entire point? Well, let's get into that. We want to analyze the motion of a spring mass system with the mass shown oscillating in an arc kind of motion. And we're going to use our beloved tracker to document every position. And we're also going to use GlowScript to predict and graph the object's energy and motion. And this was all done. Why? It was all done to see if the computational model showed us the energy principle in action. So let's see. Over here, we have our fundamental principles, a physics fan favorite, Newton's second law for I think the fourth time with the labs. So we know Newton's second law, and then over here is just a little picture of our spring mass system with spring and gravity forces acting upon it. But for this lab, our main focus is the energy principle. So what is the energy principle? The energy principle says that the sum of work is done by surroundings and thermal energy exchange with the surroundings themselves, and that entire system represents the system's change in energy. So in this lab in particular, we're eliminating um, any interactions with the system. So that's why everything over here results in zero. And then on the right over here, we have our formulas. These are just some nice update potential energy formulas that we have learned along the way that we're going to need to use when we're coding. So let's see. So the video that I used, this was the video that we were given, and we're looking at the x and y values. So I looked at the graphs over here, and so if you look from peak to peak, this is called an oscillation period. And if you average the peaks and everything, you can get the result that you need. And the result that I got was approximately 1.5. And then I solved for the spring stiffness for K, and I got approximately 6.753. And then I also solved for the relaxed length, and that I got approximately 0.113. And this is all done so that we know our initial conditions. And we also have more initial conditions over here. And I just inputted them so that I could start with my tracker journey. Let's see. And then over here, I put in the spring lengths, as well as the spring direction and the system's energies. Uh, and this was done by using those crucial formulas that I showed you in the previous slide, and the ones that we've been learning in class. So over here, this is going to be a lot of code. So the while loop, what we're looking at right now is a while loop that is continually iterating through our data and calculating the change in energy. And then boom, we calculate the gravity and the spring and net force. And then from knowing the net force, I figure out the net position and the velocity. And then from there, you're able to find the potential and kinetic energy, and eventually the change of energy at each step along the given data from the video. And that's shown here at the end. So here we're looking at some good old oscillation, and we see that they're pretty much aligned. If you look at the red and blue lines, they're pretty much aligned. But as we go on, they kind of start to misalign a bit. And why is that? Here's some human errors. I mean, it's an extremely tedious task to be putting in all the data points into Tracker. So that was human error partially. So maybe I didn't get the most accurate center of mass placement. That could be an error. And then also, we didn't take into account the surroundings. So in reality, we have to acknowledge the surroundings because they do add up to equal work, right? That was not shown here. So let's talk about the energy principle. Was it demonstrated? Well, the energy is zero because no outside forces are affecting the system. And then the total change is consistently zero. If you look at the graph here, you can see it's consistently zero. And because of that, and because of what the energy principle stands for, we know that, yes, the principle was satisfied. Yay! So happy. And then let's talk about the oscillation periods. Oscillation, that is some slang that Gen Z is using nowadays, but it's oscillation periods. And so after calculating and doing some calculations, I got approximately 5.6 and then 6.4 for the different periods. And so why is that so? Well, when you look at different directions, there's going to be a little bit of numerical divergence, but nonetheless, everything's okay. And that's what we see here. Everything's still going to be the same. Well, I mean, yes, it's different over here. We can see that the different directions will show different numbers, but there's going to be deviation. So I'm saying that there's still going to be deviation. But yeah, thank you so much for listening to my video. And this is thank you in sign language. So that's just a fun thing to learn as well. And I hope you have a wonderful day. Thank you so much for grading my lab.